All right, so we are picking up where we left off. Now, when I say where we left off, I mean where we left off on the video that I posted because we didn't have class last Wednesday. By a show of hands, show me if you watched that video. This is going to be tough if you're the ones that haven't watched the video because it's going to be coming out of nowhere. We are picking up on an example that we started there. I'm going to give you a little bit of a reboot then, and hopefully we don't just lose you all together. If we do, basically go back and watch the video from Wednesday and then probably watch the video from today again. Looks like I am sharing. I got my camera on. I got to turn my camera off. It's not video. There we go. Okay, so to review, we have this idea called an array. An array is a general topic in almost every programming language. It has the notion of an array. An array in VBA, and are different in different languages, but in VBA, an array is an array of variables. So the word array is just a word in the English language, right? I can kind of look at it and say, you know, I see a beautiful array of students. You know, what else might I see as an array here in this classroom? There is an array of, kind of also looking about where the students are. There's a beautiful array of chairs. Here's an array of steps. There's an array of pattern, whatever those sound things are on the wall. There's an array of lights, right? It's just a grouping, but arrays are always arrays of something. It's like an organized set of something. And in VBA, when we say an array, we mean an array of variables. So it's just a bunch of variables that we declare all at once with the same statement. We just say dim. In fact, let's just kind of review the code as we're going through this. So here we are saying dim hotel as string. In fact, let's look at this one that we have commented out. Dim hotel 35 as string. I am making many variables all at once with this statement. How many am I making? 36. Yeah, because arrays start counting at 0. And what I put here is I put the top index that I want to create. And so this creates 36 variables. They're all named hotel. And so there's confusion about, you know, which one's which. And so when I refer to it, I need to refer to it with its index. So I could put, if I was just to put you just open my immediate window here. So if I was just going to pick one of those variables, I would say hotel. Is it hotel or hotels? Hotel sub 4. That is the number 4 variable in that array of variables. And then I could do anything I would do with a variable. I could say, you know, that equals the Hotel California or the Hotel Utah. And so the point is, when I make an array, I'm just making many variables all at once. Now, another thing we did is kind of a couple of things that were new in that video. And one is that every time we've declared a variable before in this class has been inside of a subprocedure. Variables that are declared inside of a subprocedure, and this is true whether they're arrays of variables, just regular variables. When they're declared inside of a subprocedure, the memory is actually allocated when that subprocedure starts to run. When you say, hey, run that subprocedure, the interpreter says, well, we got some variables here. Go get some memory for it. And when that subprocedure is done running, the interpreter says, we're done with all that memory. And it gives it back to the operating system to do with it as it pleases. If we declare a variable up here at the very top of the module, it has a longer life. It gets declared as soon as I run any code in the module. And as long as code is running, it stays declared. So I move from one procedure to another and call this procedure and that procedure. The variables that are declared at the module level, the module scope variables, then they stay around. And so by declaring these variables up here, both hotel and dist, we're going to have the ability to refer to them from any of the subprocedures in this module. Whereas if I declare it inside a module, it's only available inside that module. And the reason that we're doing that is because we're making a procedure here that's going to initialize the arrays, going to be able to put values into the arrays. And then later we'll have other procedures that we want to be able to use. Did I lay the problem out? I think I might have started recording the video a little bit late. Do you know what the problem we're trying to solve here is? This is the traveling salesman problem. You're familiar, if you're familiar with the traveling salesman problem, just raise your hand real quick. Okay, we missed this from the video. It's only about half of us. Traveling salesman is a problem that mathematicians have been working on since the 1700s. Like mathematicians make their career on this particular problem. Here's the idea. You need to go from, you have a traveling salesman who needs to go to these different cities, and they're all over the place, and he's got to go there, and some versions of the problem he has to end up back where he started, some he just has to go to all of them. But the question is, what's the shortest distance to travel? How do you figure out, all is like the road distances between each of the cities. How do you figure out what the shortest distance is? And so the problem that we're looking at here today is, a similar variation of that. The data that we have to work with are these hotels. So you're going to suppose that you have been hired by the Starwood Corporation to work in their Western regional office. And before you show up, no one knows you work for Starwood yet. Before you show up, your boss says, hey, listen, I'm going to have you kind of go out, and we've got some hotels that are doing really great, some that are struggling. I just want you to go and just kind of observe things that are happening there. So we're going to give you here a corporate credit card to spend all you like, go eat at the restaurants, go to the masseuse, do everything that's there, and just kind of keep notes. And then when you start, you'll have kind of a background for this, and you'll give us some advice and so forth. And you say something like, well, wow, that's going to take a while to do. I've got a family. I said, no problem. Rent a van, take the kids with you, and just, be great. You got 3 months to go to all these places, or 8 weeks. I don't know how long. You got some time to do that. And so, you're now faced with a traveling salesman problem, because you want to travel. You got to go to all of these, but you want to go in the time that is the least time on the road. Right? Because every hour in the car with the kids is one less hour at the masseuse, right? So you want to reduce that time. Okay, so how are you going to do it? How are you going to figure out what's the shortest route? This is the classic traveling salesman problem. I know the answer. Yeah, that's right. The only way to be sure that you have, to this day, the only way to be sure that you have the shortest distance is to calculate every possible route and just see which one's shortest. We've been working on this problem for hundreds of years, and that's still the only known solution. That is still the only known solution. So, people that make their careers out of this problem, they try to say, what, we're 99% sure that we've got we're not positive, but we're 99% sure that we've got the shortest distance, and something that we can actually calculate. By the way, we've got 36 properties here. So how many different routes are there between these 36 properties? I'm always amazed that someone can just roll this off the top of their head, because I had to think about it the first time. How many different routes are there between those 36 properties? Yeah, someone just said it, 36 factorial. Is that a big number? That's an unbelievably big number. Fortunately, we actually have a function that does that for us here. Let me just, we have some, I guess I'll do it right here. I'll come to the bottom and put it right here. Okay. So fact, not question mark, equals fact 36. I never was that good with scientific notation. So let me just format that with commas. I don't think I need the decimal points on the end. That's how many possible routes there are between these 36 cities. When I first was doing this problem, when I first introduced this as an example in class, I thought, oh, you know what? We can just calculate them all. I got a computer. We'll just let it run. So I wrote a program to just start calculating them all. And it was pretty clear it wasn't going to run straight away. I'll just let it run overnight. So I let it run overnight. And the next morning I came in, it was still cranking away. And I interrupted it and I thought, wow, it didn't really make it very far. I wondered how long it would take. So I timed my computer. This was a while ago. But it could calculate 5,000 routes in a second. So take this number divided by 5,000. That's how many seconds it's going to take. Take this number, divide it by 60 minutes, divided by 60 hours, divided by 24 days, divided by 366 roundup. What the heck? That's how many years it would take. Okay, my computer's never going to do it. Okay, if it has a power failure or something like that, and I got to start again. So I read not long ago that the 1 billionth PC had been produced. So let's just use that as a surrogate for the computing processing of humanity. So it's What if we didn't get my computer? We got everyone's computer involved in this. Divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9, 1 billion. That's how many years it would take if we devoted all of humanity's processing capacity to solving this problem. How long has the universe been around? Best scientific estimate for the universe, anyone know? I just don't even know what that number is. It's about 20 billion years? Yeah. So we're gonna divide this by 20. Now I got a number I can say. That is hundreds, thousands, millions, billions. If we dedicated all of humanity's processing power to solve this one problem, it would take 117 billion times as long as the universe has been in existence to be sure that we had the right answer. You could pick the worst route and drive it dramatically faster than you could find the fastest route here. And so, we're not going to be able to be sure that we have the fastest route. So, what's another option for us? Like, what's an algorithm that would give us a route that would be a pretty good route? Turns out, there's the one that's kind of pretty easy for us to calculate. It's called the next nearest city route. So that says start somewhere. Where are you going to start? We're going to start in Salt Lake City because it's pretty close to where we are now. And Salt Lake City is like the second hotel up here. And then what this row shows us is it shows us the distance between Salt Lake City and everyone else. So what should we do? We just pick the shortest one. Let's just go to the closest one to Salt Lake. And then once we've gone there, which is going to be Las Vegas, by the way, which is like, where's Las Vegas? Right here. So if we look across that whole row, we would see 425 is the smallest number there. And then we'd say, okay, now that we've been to Salt Lake, we're going to go to the closest city that is not Salt Lake. Yeah. So that we haven't been to yet, because it turns out the closest one to Las Vegas also is Salt Lake. We don't want to go back to Salt Lake. So that's what we're going to do. And so we're just going to go find the closest one, find the closest one, find the closest one, find the closest one, and we'll be able to actually calculate a route. And so it should be no surprise that we're going to be using arrays to do this. Could we do this? Could we solve this problem without using an array? Absolutely. We could just refer to the data that's right out here on the worksheet. But it turns out accessing data from inside the array is dramatically faster than trying to read a value off of a worksheet. And so if we've got an algorithm that has to crank through and makes lots of different comparisons, then we're going to get significant speed improvements by saying, hey, read the stuff off the worksheet, put it in memory, and then we can just manipulate all of that in memory. And so that's what our task is. And so what we've done so far to solve this problem, we said, listen, let's go ahead and get some of this data loaded into 2 arrays. So we've got an array called hotel. Now, this array we're not saying how big it is when we're making it. This is called a dynamic array. And it just says we're just going to get ready, VBA interpreter, because I'm going to need an array. And it's thinking, well, how many variables you want in the array? And I say, I don't know yet. I'll tell you later, but just get ready. That's what we're saying here. So before we can actually use the variables in this array, we have to redim it. And so here's the idea. Because declaring the arrays or variables all happens before any code runs, we can't ask how many, we can't look at our worksheet and find out how many variables do we need before we declare the array. But if it's a dynamic array, we can say, hey, get ready for it, and then go figure out how many hotels we need. So we make this hotel count variable, and then we can redim the array to that size. And that says, all right, we now have an array of that number of variables. And that's what we've done here. So we're getting this thing going. We've got the array declared. We've now redimmed it. So we've got 36 variables, numbered 0 through 35 in this array. And then we have an array called distance that we're going to use to the names of our arrays and the distance to keep track of the road distances between each of the hotels. Now, I'm going to come over here to sheet. I made a sheet called arrays. Now, it might be a little bit confusing because you'll look at this and, hey, that's on a worksheet. But what this is that this is a visual representation of what's happening in memory. So we've got an array called hotel, right? You don't see them. They're just variables in memory. It is declared with 36 variables numbered 0 through 35. And then we want to actually plug the names of all the hotels into that array. And so let's just kind of look at the code that does that. So we have here a loop we're going to do until our worksheet called distance, row is starting at 2. Looking at whatever row it is, the first column, we're going to do that until we hit a blank cell. You'll notice, unsurprisingly, we'll be adding one to this loop each time. And so we are looking at our distance sheet. We're starting here, and that loop is going to continue to execute as we go down this until we run out of data at the bottom. And so once we hit that cell that's blank, it'll be like, okay, you're done with that. And so as we are going through this, we are saying, as row is going up, and we're using that to read a value off of the worksheet at row number row. And then we're going to write into the corresponding slot in hotel. The indexes start at 0. So when I read from row number 2, I'm going to write at row number 0 in my array. So variable number 0 is going to get whatever the name of the first hotel is here. It's going to be this Sheraton Los Angeles Downtown Hotel. And then as I move down this sheet, I'm incrementing that variable, which lets me write to the array. And so my array then at spot number 0 has then those names. And that's really how far we got on the video. And so you think, wow, we spent the whole video just getting there. We don't even have the problem set up yet. And hopefully by the end of today, we'll have this problem solved. So our next step is to fill in our distance array. And we got started here, but the code really isn't doing it. So let's take a look at where we are. So this, as we go through the arrays, that loop is going to fill up our hotel names into that hotel array. In fact, let me just go ahead and I'm going to disable this for just a moment. And I'm going to run this code. See, and we're stopping here at the end. Okay, so right now, if I just I'm still in break mode here, so I can look at my array, hotel. I can look at the hotel number 0, and it's got that value in it. Hotel number 1 should have the Salt Lake City property in it. Now, we've got the hotel array loaded up with its values. Now we're going to try to load up our distance array. So our distance array is declared here. It's a distance, but when we redim it, we are giving it 2 indices. So we're going to think of this array as an array of variables organized in a grid. We'll have like a row and a column. We can do 2 dimensions. We can do 3 dimensions. We can think of it as a cube. We could do 4 dimensions, which is kind of hard to think about, but you can have as many dimensions as you want in an array. There's probably a limit like 32 or something, but there's lots of dimensions that you can have. So now what we're saying is that when we want to refer to an element in this array, one of the variables that's in this array, we are going to have to give it not just 1 dimension, but we'll have to give it like a row and a column, because conceptually we've organized those into a grid for us to be able to deal with. And so when we come down here and we're looking at row number 2 in our data sheet over here, we've just put this variable into the hotel array. And while we're on this row, let's go ahead and put this row into our dist array. In fact, I need to rename this because I called this distance, and that's actually called dist. Well, remember that every time we declare a variable, there's going to be a default value. And also strings get defaulted as a 0-length string. All numeric variables start at, the default value for any numeric variable type is 0. And so when I look at this sheet here, that's blank, but what that really is this is the distance between this hotel and this hotel, which is the same hotel. So what is that really? This really is 0. Which is really common to leave that blank in these kinds of representations. And the good news is, when I first made my array of variables, they're already all filled with 0. So I don't even need to deal with this one. It already has the right value in the array. So I want to start right here. So when I'm on row number 2, I want to start looking at my distance variables in column number 3. That's where the data are. This actually is not here on our data. Our data is just blank here. In fact, when you have a table like this, if it has information in the top and bottom, what's typically the difference? Have you ever dealt with these kinds of tables? So this is like miles between the two, and then this is exactly the same, right? This is between Sheridan and Salt Lake City, 1, oh yeah, so this one right here, between Salt Lake City and Los Angeles, that's how many miles it is. This is also the distance between Salt Lake City and Los Angeles. And so quite often you will see these filled up with kilometers on the other side. So kilometers on one side of the diagonal, miles on the other side of the diagonal. So I've left it a little more simple here, but the point is I definitely don't want to just read across this, even if it's full, because I'll get kilometers for some of my measurements and miles for the others. And so I'm just going to just fill in this part of my distance array for starters. So when I'm on row number 2, I want to start on column number 3. When I'm on row number 4, I want to start on column number, row 3, I want to start on column number 4. When I'm on row 4, start on column number 5. So what we're going to do here, as we're thinking about this inner loop that's going across the column, right? So row is going to be held constant, and we're going to loop across this column. Instead of starting at 2 each time, I want to start at something different based on the row I'm looking at. And so whatever row I'm on, I just want to look at the next column over. So as the first time through this loop, when row is 2, this loop is going to start at 3. This is the first time that we have had anything other than just a constant numeric expression here. Right, so we've done some arithmetic to figure out where this loop's going to start. So this inner loop is not going to iterate the same number of times each time. The first time through, it'll iterate 35 times, then 34, 33, 32, all the way down to 0. Because when we get to that last one, there's a 0 there. Why is there a 0 there? I think that must be a rounding error. This is Sheraton Santa Ana Hotel, Santa Ana, Seattle. Someone look up Sheraton Santa Ana, see if it's in the Seattle area. Anyway. Yeah, we've got others that are 0 here, and this is a cluster where they're really close to each other. So I think it's just rounding that's happening. Okay. So let me go ahead and run. Let me stop my code and run it up to here now. And look at hotel. Sub. Let's do sub 1, which is our Salt Lake one. And now if I look at distance, looking at, so anything I see on the row where Salt Lake is should be distances between this thing and Salt Lake. So if I look at row number 1, column number 2, that should be the distance between Salt Lake and row number 1, column number 2, whatever that is, Salt Lake and the next one over, which is Salt Lake and Phoenix, 653. So let's see if that's what we have. Yeah, 653. So that's the distance. If I look for the next one over, column number 3, that variable is holding 662. That's right. Next one should be 659. Okay. It's a little bit abstract, right? We've taken the data off of the sheet and we've just loaded it into memory, into a bunch of variables that are conceptually organized in a grid so I can use indices to refer to them. Show me how comfortable you are with what we've done so far on 0 to 5. We've got some at 5s. I'd be surprised if there's not some 1s and 2s out there because this is new stuff. Okay, looks like most of you are feeling pretty good about it. All right, so now we have not put anything into this location here yet. So if I look at my distance array sub row number 01, so row 1, column 0, then it should still be 0. Because we haven't put that value in there. But we want to put the value in there because, listen, if we don't put the values into that part of the array, then if I'm trying to figure out the distances between this hotel and everything else, I've got to look up there. I've got to kind of go vertically for part of my problem, and I've got to go horizontally for part of the other problem to figure out what all the distances are. It would be so much easier if I just took those values and plopped them in here in transpose. There we go. So if I had all the values then put now this thing fully specified, Now, each row shows me the distance between one particular hotel and all the rest. Each column does as well. So I can either work across the rows or the columns, but that'll really help to simplify things. So our code right now fills in this part. So what do I have to put here? How do I know what to put there? How do I know what goes here? Yeah, say it. You signed it, but I don't speak sign language. I think that's American Sign Language you're doing. That's right. Just I just have to switch the indices. Because when I write in here to row number 2, column number 3, I want to write into row number 3, column number 2. So yeah. Okay, so in fact, it's probably simpler to see it this way, even though it's a little less efficient to read off that worksheet again. I'm just going to switch my indices. So I'm going to I'm just going to reverse these. Yeah, so I'm writing into a different part of the array, reading from the same part of the worksheet. Oh, okay, let me go ahead and run this code now. And now I should be able to actually get the value by looking at, and it should be the same value if I look at 1, 0, or if I look at 0, 1. And so that's looking good. So now we've got this array, our distance array, we've got fully populated the way that we're showing it here on this sheet. Questions? Okay, now we need to introduce another array. I don't think we've made it yet. We're going to need an array called route. And our route array, or maybe it's called root, I don't know, but it's this one. And so what we're going to do here is we're just going to plug in the indices of the hotels in the order that we're going to them. So we already know we're starting in Salt Lake, and the index for Salt Lake is 1. So I'm going to plug in here 1. And then our next one I happen to know is going to be Las Vegas. And so the next one's going to end up going at 7. And I forget where the third one is. But that's what this is going to be for. This is going to keep track of as we're figuring out where to go. That's the one that we're going to go to next. That's why it's going to be called route. So let's just go ahead and get that built. I'll stop my code. And I'll do the same thing up here. Let me dim another variable, dim route. The dynamic array, so I'm not going to tell it how big I want it just yet, also as integer. And then when I'm redimming my hotel, my route is going to be exactly the same size because I've got to put each hotel into the route once. So I will redim route to be this size. So now I've created that other set of 36 variables ready to keep track of my route. Now, I'm going to be querying that route because I have to, when I'm trying to figure out which city I'm going to next, I've got to go to the cities that I haven't been to yet. Well, how do I know if I've been to a city? Like with the structure that we've got here, how can I tell, let's say I'm trying to figure out number 2, how can I tell, by the way, don't go back to Las Vegas, don't go back to Salt Lake City. I can just look at those and say, if I'm considering how close a particular hotel is, I can just say, hey, is that hotel already in my route? If the hotel is in the route, don't consider it. If it's not in the route, it's one to be able to consider. Now, little problem here, because remember, all numeric variables get a default of 0. So when this route array gets created, it's not full of blanks, it's full of zeros. So what does that mean? Like in the definition of what we're using this for, what does that mean? It means what's that? No, because what we're putting in the route is we're putting in the index number of a hotel. So what does our route say right now? Start at the one in Los Angeles and then go to Los Angeles and then to Los Angeles. So just no reason to leave Los Angeles. And that's going to be a problem because when we're trying to figure out what we should go to next, if we're asking, is the hotel already in here? Kind of inadvertently, the answer is Los Angeles is already in here. And so we need to do something to get this thing off of those zeros to start with. So what would be a valid number that we could put in there? We gotta have some number. Like any numeric variables, they're never blank. They are a number. So what would be a good number to put in there? A little louder? Oh, put one that's outside of the boundary. So we've got 35 will be our top hotel number. So we could fill it with 36s. That would work okay. Other options? These are integers. Say it again. Did I hear it?
Because if it's a fraction, it won't tell us.
Oh, we could put in like 0.5 or something. But because these are integer variables, if I put in a 0.5, it'll round it to 1. So I can't just put in a fraction. 36 is a great number to put in there. I got to think about it though, because I got to actually calculate that. I mean, the other end of the spectrum would be like -1. Like -1 is never going to be a hotel number. You know, even if this problem grows and we have more to deal with the next time. So let's just go ahead and initialize that one as well. So yeah, we'll do it right here. So right when we write the hotel's name into here, let's do the same thing for route. So route at row -2 equals -1. So now that's how our route is starting out. Okay, so I think we're in pretty good shape to try to start solving the problem. Ooh. All right, so in fact, I think now our initialize array, I'll get rid of my little stop statement here. We talked about read and preserve on the video. I'm going to get rid of that here. And so that now is going to fill up my, it'll initialize my arrays to have the starting values in to start doing the calculations. So I'm ready to make another sub procedure. Let's call this sub procedure calc route. And so this one is just going to actually do the calculations. So any thoughts on how to start here? Well, we better start. We're going to just run calc route. So we better start this by saying, hey, why don't you go ahead and initialize our arrays? So I'm just going to say initialize the arrays. So step one, when you're calculating the route, load the information into memory. Now, I would like to say start at Salt Lake City. So in this, the way I've set this problem, how do I start at Salt Lake City? How do I indicate where any hotel is in the route? I'm going to use my route variable, my route array. So I'm going to say route sub 0. I'll just hard code my starting point equals what? Should I put Salt Lake City? That won't work. And why won't that work? Route is an integer. Okay, so what should I put in to say Salt Lake City? Yeah, 1. Because the hotel index, my list of hotels over here, for Salt Lake City is 1. And so I'm saying the index number 1 means Salt Lake City is in the route. Now I'm ready to figure out what the next location of the route is. And the algorithm is, I want to find the shortest distance, but the shortest number between Salt Lake City and every other property that I haven't been to. And because I've just done this, I now have been to Salt Lake City. I recorded that been to Salt Lake City. So let's just make another function. I'm gonna use it here, and then we'll go define it. So I'm gonna say, and I'm gonna hard code the first few of these, and we'll make a loop for it. I'm gonna say route sub 1 equals, and then I'm gonna make a function called next hotel. And I'm gonna pass it the hotel that I'm currently at. What hotel am I currently at? Salt Lake City. I'll leave this hard coded for now. Once we get the pattern, and then we'll make a loop out of it. Okay, so let's go make a function now called next hotel. Function next hotel. Next hotel is going to take a current city or a current hotel as input. So current hotel as an integer. And this is going to return an integer. Return int. INOS. Okay. So now we just have to actually do the work of that. So we've passed in the 1, and now we just need to look across my whole array to figure out what's the closest city to Salt Lake that I haven't been to yet. Ooh. So we're going to need to loop across something in the array. So let's declare a variable for that, dim x as an integer. And now let's just look across like all of the distances that are relevant for Salt Lake City. So which part of my distance array am I going to be interested in? Like this row right here, right? This one, like this number here, doesn't involve Salt Lake City at all. I don't care about that number. I only care about the ones either on this row or this column. They have exactly the same information in it. So let's just start off by making our loop actually print that vector of numbers off. And then once we know that we've got it looking correctly, we can think about which ones do we actually consider. So for x equals 0, 2, and then we're going to look at whatever the upper boundary is. So because my arrays are all the same size, I could look at the distance array and ask what the upper boundary is. I could look at the route array or the hotel array. They all have the same upper boundary. Distance array has 2 upper boundaries, so it's a little more difficult. So I'll use hotel. And there's a function called ubound that returns the upper boundary of an array. Now I'm going to print off all that set of numbers. So I'm going to be looking at my distance array, looking at row number 1. We'll get that unhard coded here in just a second, and then x. Why am I interested in row number 1? That's Salt Lake. Well, I want to use this not just for Salt Lake, but anytime, and that's why I'm passing the current hotel in here. So I'm going to look at my current hotel and run that set of numbers off. So when I run this, let me get it so I'm going to get rid of my debug.printing that I have out here when I'm initializing. I don't need to see that anymore. Okay, so now when I run next hotel, what I should see is that vector of numbers, all the distances from Salt Lake. Elk route 691, 0, 653, 662, 691, 0, 653, 662. So I've got them. And if I was a little unsure of myself, I could go and verify that they're all that way, but we're in good shape. Maybe I will check the last one. Last one is 841. 841. Okay. So now I just need to figure out, for those of you who have tried the homework already, this should look vaguely familiar, because I'm trying to figure out, which is the shortest, the closest one that I haven't been to yet. So let's start off by saying I only want to consider ones that I haven't been to. So I'm going to need an if statement right here. I have something in here, if, then, and if. And here I'm going to say, consider hotels I haven't been to. So how do I figure out, how can I tell if I've been to a hotel? Oh boy. I got to loop through all of the hotels in my route and see, I'm going to be asking, have I been to this hotel? And I got to check to see if the index for that hotel is in the route. Sounds like another function. Man, we're making functions left and right today. Another function. I'll call it been there. And I'm going to pass it in a hotel index. It's going to return, what should I have this thing return? Yeah, true or false, Boolean. So it's going to be as Boolean. So it's going to return false unless I tell it to return true. Oh. I now need a loop that's really similar to this one. So I'm going to copy my dim and my for statement. Next. Okay, so now I'm looking across the route array. So maybe I'll use route to find it, just make it a little clearer. And that's my hotel index. So what I want to say is if, so here I'm now inside this loop, I'm looking at every one in my route. Let me bring route over here where we can see it. Okay, so when X is 0, I'm looking at this slot in my array. And by this time, I've got 1 here in my route. So I want to see if the hotel number that was passed in matches the hotel number that I'm currently looking at the route. So if route sub X is equal to hotel index, what does it mean? If this is true, what does that mean? Yeah, we've been there. So the way that been there is going to tell me we've been there is we're going to set the name of the function equal to true. Is there any reason for me to keep looking for more hotels? Like what would I return if I found the hotel number in there again somewhere? Really true, extra true, double true? There's no reason to keep looking. So here I've set the return value, and now I'm ready to exit my function. And so now this one, I can call this, pass it a hotel index, and it will just tell me true or false if I've been there or not. So when I'm trying to figure out which hotels I should be considering here, I'm now looping across all of my hotels, looking at the distances. I'm now just going to say, I only want to consider this if I haven't been there. So if not been there. And I'm going to send it in X, right? Current hotel is the one that I'm currently trying to figure out the distances from. X is, as I'm looping across this, that's the hotel number that I'm looking at. So if I haven't been there, then I'm ready to consider these. Let me just do a debug.print in here and make sure I'm getting what I think, because at this point when I run it, I should not see 0. If I'm just printing the indices, I should not see 0 because 0 should be one that I've been to. And so I should see 1 and then everything else. So debug.print X here, and that will be the indices of the hotels that I have not been to. So I should see, I'm looking at the indices. So I should see 0. I shouldn't see 1. I should then see 2 and then the rest. In fact, maybe I will put a breakpoint and run this. Okay, so I'm going to run my calc route again. I'm now calculating next hotel. I should be able to see my current hotel is 1 as I expect. So X is going to start at 0. Printing off the distance there. Let me clear off my sheet here. Print off the distance. Now, if I've been to 0, then I should skip this loop, but I haven't, so I should come in here, print the 0. Now I'm looking at the next element. I'm looking at my next column here. So my index is 1. 1 is in the route, so I should not drop into this if statement. So I'm doing Shift F8 to step, and I step, something's wrong here. X is 1. I have been to 1. I think I've been to 1. Yeah. I'm going to open up my locals window and just take a peek and look at what my arrays look like. So let me view locals window. Here is my route. Yeah, it's just as I expect. I've got the 0 there. So something went wrong here. So we can go ahead and step through that one. I'll come back here and use F8 instead of Shift F8, which will let me step into that one. So X equal to 0, 2. Oh, this isn't route. That's the problem. This is U-bound of route. Change the wrong thing. So X is going to start at 0, and it's going to go until we get to however big that route is. Yeah, and as I stepped into that, we found it immediately. We're now exiting, setting true, and so we skipped over that statement. So yeah, I had just did that hastily. So instead of changing the name of the index, I changed the name of the function. I'm surprised it didn't give me an error, but I guess it was actually reading that array, that variable, variable in that array and returning a value. So now I think I'm in pretty good shape. So now we are only considering, we'll only make it into here if it's a hotel that we haven't been to. So I'm going to go ahead and just run this off and make sure it looks right. I've got a debug.print down here somewhere. Initialize array. Yeah, I don't really want to be printing the distance. I just want to see my indices here. So I'll run this again. Yeah, so it says, yeah, we're interested in thinking about going to Los Angeles. We're not going to go to Salt Lake City. We're going to think about going to whatever these other hotels are. Okay. So now we've got to figure out what's the index of the smallest number in that vector. How many of you successfully have already done the homework? This is kind of the hardest homework, not project, but the hardest homework of the term, I believe. So if you've done it, so give us some thoughts. How should we tackle this problem? Don't have to solve the whole thing, but at least get us started. Or I can do it. Turns out I know how to solve this problem. I've solved it like 100 times. Twice a semester for 20 years. Or I've solved it 40 times. Okay. So we're going to need, so we got to keep track. We got to be able to remember what the smallest number we've seen is. So right now, let me go ahead and move my print the distance. I'm going to move this inside the loop. So we're only printing off the distances of the ones that we care about. So we'll print X, and then we'll print the distance that pertains to it. So let me just run that off so we've got the numbers in here to look at. As I'm going through this, I've got to look at this vector of numbers, and I've got to say, what's the smallest one? When I read this one, that's the smallest one I've seen so far. I got to keep track of it. And I got to keep track of the fact that I saw that at the number 1 index or the number 0 index. And then I'm going to look at this one and I'm going to go, oh, hey, that one's smaller. That's now the smallest one I've seen, and I got to keep track of where I saw it. So remember that I saw that at 2. And then I'll go to this one, and this one is not smaller. It doesn't change. I go to this one. Let's have a little more room here. So my smallest one I've seen so far is 653. That's not smaller. That's not smaller. I get to this one. Ah, that's the smallest one I've seen so far. I got to remember that's the smallest one I've seen so far, and I got to remember where I saw it. This one doesn't change. I get to this one and go, ah, that's the smallest one I've seen so far. Remember that I saw that at 7. And this problem, I'm never going to see a number smaller than 425 as I keep going through this vector. So we just have to figure out how to do that. So I got to keep track of those two things, the smallest one I've seen so far and where I saw the smallest one I've seen so far. Let me give myself a couple more variables up here. I'm going to call this short distance. short distance as an integer, and I will dim short index. So the index of where I saw the shortest distance also as an integer. Okay, so now I'm inside my if statement. So I'm only looking at ones that are possibilities. I'll print that off and I'm going to say if, yeah, I'll write this here and then we'll see what the problem is. If the one I'm currently looking at is smaller than the shortest distance I've seen so far, then we'll do something. So this is, we found a new contender, a new possible shortest distance. The problem is we won't know if it's really the shortest distance until we finish off the rest of them. Okay, so we've got to do something here, but what is the problem with this? Short distance is initialized to 0. Am I going to find any number that's smaller than 0? There's no negative distances. And so I got to do something to initialize that so it doesn't start at 0, it starts at something bigger. Some number that I know that when I make the first comparison, it'll say, ah, that one's smaller. So what are some possibilities? Let's go ahead and get short distance initialized. Short distance equals, what should we equal it to? Set it to. It's an integer, so I could put like the maximum value for integer, 32,767, or I think it's 7. Or I'll put in 24,000. Why 24,000? 24,000 is roughly the circumference of the Earth. Listen, if the distance between this hotel and the next one is more than 24,000 miles, you went the wrong direction. Now it's not a straight, you'd be going on roads and we'd probably have to go on an ice bridge or something, but that's wrong. So that just says, make it so when we make the first comparison, we'll say, ah, that's my best contender. So now that should be okay. So now once I find a contender, I got to keep track of it. So I'm going to say my short distance. I got to keep track of what's the new shortest distance I've seen. I'm going to move that from 24,000 miles to whatever distance I saw. It's going to be 691. And so that's going to be the thing that I printed out, like that value off of my dist array. And I got to remember that I saw it there. So short index equals X. All right, I'm going to go ahead and step my way through this. And let me take off the debug.print so that I can just kind of think of as we're going through here. So let me come and step right here. So if not been there, X, I'm looking at 0. Let me come in here and just kind of put the 1. So that's actually the vector that I'm working with. So not been there, X. Am I going to drop into here? So right now, X is 0. Have I been to 0 yet? No, so I should come into here. Now, is my short distance, which is 24,000 miles, is my current distance smaller than the short distance? Yes. So in fact, can I highlight this and look at it? Yeah. So I can highlight that. It's probably tough to see from where you are, but that tells me true. At this moment, that's true. So I should drop into here. Now I'm going to record that as my new best short distance, and I'll remember that I saw that at 0. Next time through, not been there, X. X is now 1. Have I been to X already? I have, so I shouldn't drop into this one. In fact, I could highlight that, and I expect that to be false. Or I can come up here and actually just print that out. I can like right click and print that expression out, and that'll tell me we know what it is. So I'm not going to drop in for 1. Now we're looking at number 2, and this one's smaller. So I haven't been to anywhere else. So I should drop into all of these. And this one should be smaller. So we'll go through that one. And yeah, we got into there. So that's our new contender. We're remembering that we saw that at 2. Next time across, I haven't been there yet, but now I'm looking at this number here, and 662 is not smaller than that one. So I don't think I'm going to drop in. Yep, we skip right by it. Next one I've been to. I'm now looking at 659. It's not smaller. So I skip by that one. I'm now looking at 659. 650. 650 is smaller because my old contender was 653. I'll kind of mark that as my best contender. So this one I expect to drop in. Yep, and I remember that's where I saw it. So that's the next one. Mark that as one that I've been to, or that my new contender. I'll keep going. My next one is 661. That's bigger, so I'm not going to come in this time. Next one is 425. I am going to come in this time, and I will skip every other one because there's not a number that's any smaller than that. So now you put a stop out here and just run till I hit there. So at this point, I should now have route sub, oh, did I return? I haven't returned the value yet. So this returned 0 because I haven't told it what to return. So at the very end of this, once I've been through this, I just need to set the name of this function equal to my short index. And that should then return the value. Let me take this breakpoint off, and I'll run to this one now. And so now I should have a value in route sub 0, should be Salt Lake. And then route sub 1 should be Las Vegas. And in fact, I could actually see those names by taking those indices and feeding those to the hotel array, because it just takes that number and gives me the name. So now it says, start in Salt Lake City, go to Las Vegas. What's in route sub 2? Just going to be -1. That should be an error because there's no -1 in there's no hotel with a number of -1. Oh, man. We've now calculated the next distance. Let's do the next one. So I'm going to just copy this line again. And so now route sub 2 is going to be next hotel sub 7. Next hotel starting at Las Vegas. That's what that says. We'll go ahead and calculate that one. Control Shift F8. So now if I look at route sub 2, tells me we're going to some place called Fairplex. Like what is route sub 2? So that's number 12 is our next one. Okay, so route sub 3 is hotel starting at 12. It's looking a little bit difficult. I'm going to run this one, F5. And we can look at our next one here. So number 3. Next one says to go to 19. Anaheim, that's in the Los Angeles area. So the next one is going to be route sub 4, starting at 19. Okay. I don't want to write all of these out. I want to have a loop to do it. Now, before, when we were kind of looking at figuring out a loop, all of our indices just lined up really well. And this one does 1, 2, 3, 4. I can write a loop to count, across that range, no problem. But how am I going to get this? 1, 7, 12, 19. Say it a little bit louder. Or don't say it louder. Return the index. I don't know what that means. So you can say it softer, I guess. Other thoughts? Yeah. Yes. I put the 7 in. I put the 7 into route 1. That route 1 is 7. So whatever value I have there is where the starting is for the next one. Route 2 is 12. And so I can take route 1 and put that here. And then this is going to look at what's in route, start at what's in route 2. This one's going to look at what's in route 3. Ah, so now I've got vectors that I can control with the index. I just got to make a loop to do it. This one's different. This is hard coded. It started in Salt Lake City. I'm gonna leave that one outside of the loop. And so we'll make a loop to control this. Let me dim x as an integer. Wow, is it a problem that I have an x in like all of these sub-procedures? Are those variables going to step on each other's toes, all the same name? The answer is no, because they're declared inside that sub-procedure. They're only available to that sub-procedure, and it's a different place in memory, has the same name, but it's not, they're not used at the same time. They're a different scope. Okay, so now for x equals 1 to my upper boundary of hotel. So here is going to be x, put x in for those. And this one just going to be x plus 1. But I have a problem because that's going to take me outside of my boundary. So why don't we do this at 2 to the upper boundary? And we'll make this x. And we'll make this x minus 1. Of course, I don't need them all the same because that's why we made the loop in the first place. So now that should just kind of go through and do that same pattern across the whole range that I need. Ooh, I'll be thrilled if it works. Now sub 3 looks good. Let me just come here and say x equals. No, I'm just going to go ahead and print off the array. So after I've filled that up, let me just go ahead and make another loop here for x equals 0 to the upper boundary. The upper boundary of route. Next, debug.print. Let's see. Let me go ahead and print x. In fact, let me print x plus 1, and this will be like the stop number. So x starts at 0, so we're going to print, instead of 0 through 35, we'll print 1 through 36. Then we'll print the number that's in route, route sub x, and then we'll print the name of the hotel. And that should print off my route, F5. So let's see what it does. It says stop number 1 is 1 in Salt Lake City. That looks great. Then we go to Las Vegas. Then we go to the Sheraton Suites in Fairplex. I'm just curious. I'm sure it's got to be somewhere close to Anaheim. Pomona, California. That's kind of close to Anaheim. It's definitely in the San Fernando Valley. I don't know the valley's well enough. It's close to Los Angeles. They're both close to Los Angeles. All right. So far, so good. Where's my code? Then I go to Anaheim. Anaheim, looking great. Cerritos. I don't know. Hey, guy who said the prayer today. I forgot your name. Where'd you go? He left. He knew I was going to ask a question because he's from. What's that? Cerritos is near. Oh, you know. So Cerritos is close. Good. Long Beach is in that area. Los Angeles. I'm liking it so far. Beverly Hills, Los Angeles, Monarch Beach. I don't know where Monarch Beach is, but I guess it's there. La Jolla. Where's La Jolla? San Diego. That's pretty good. And then we're going. So we started in Salt Lake. We went to Las Vegas. We went to Los Angeles. Now we're going down to San Diego. I see a problem coming up. San Diego, because I'm kind of painting myself into a corner. I mean, San Diego is like, that's like the bottom southwest corner of the United States. You're almost Mexico. Now Palm Springs. So I went, yeah, kind of up, definitely more northern from not Northern California by any stretch of the imagination, but definitely north of San Diego. And now Bakersfield, the Central Valley, San Jose, like around San Francisco. Silicon Valley, I guess, is in the same place. It's not terrible, but if I was doing this, I probably would have gone from Las Vegas down to San Diego and then up. Sheridan, San Francisco Bay Bridge, Montreal. This one's mislabeled. I don't know. I should fix that, but we're not really going to Montreal. We look at the address. It's somewhere in that same Bay Area. Bay Area, Bay Area, Bay Area. San Rafael, Bay Area, sort of. Sacramento, a little more out of the Bay Area, but still Northern California. Seattle, it's not terrible. Seattle, that one's already somewhere in Seattle. I don't know where that one is. Ooh. Start in Salt Lake, Las Vegas, Los Angeles, San Diego, up the coast to Seattle, back to Phoenix. How are we going to fix that? We're not going to fix that. We've already accomplished what we were after here, and that was to calculate the route using the next nearest city algorithm. That's not really what we're here to accomplish. We're to accomplish doing a meaningful problem that involves arrays in a pretty substantial way. And so that is, that's the solution. So a little bit of work to actually do, and you might think, I could have done better with like a map and a pencil. Yeah, you could have, for sure. You really could have. But you couldn't do better with a map and a pencil 10,000 times a day. How many times does Federal Express have to solve this problem? I don't know, but it's a lot every day. And it's so many, you can't solve it with a pencil. Do you think their algorithm's a little more sophisticated, the next nearest location? It's totally more sophisticated than that. And not only that, their problem is more difficult because a left turn is dramatically more expensive than a right turn is. And so they've got to calculate it for, why is it so much more expensive? Why are left turns more expensive? There's two reasons why left turns are more expensive than right turns. Time and accidents, exactly right. When you turn left, you are turning across traffic and you have to wait for the traffic. And so, yeah, you'll go longer to be able to avoid the accident and to be able to not have to wait at the intersection. So why do you know all the answers in class today? Operations guy. Okay. So that's arrays, folks. If you didn't watch the video, this was a tough way to start with arrays. So I would say go back and watch the video from last week. And you know everything you need now, now to be able to start on the next project. And we'll talk about that when we get together on Wednesday. Thanks for coming. Class dismissed. What a nice crowd. You're too kind. Yeah. Come over, put your computer. Get this stuff.